Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Today's topic is vapor compression refrigeration cycle. Okay, so this is the main cycle for the refrigeration system. So before we proceed any further, let's take a look again at the closure statement. Okay, please refer to this figure here. Okay, so again, based on the closure statement, when we want to remove the heat from a lower temperature region to a higher temperature region, we must add work to the system. Okay. So let's take a look at the vapor compression refrigeration cycle. This one. Okay. So what is the main components of this cycle here? Okay, it has four main components. The first one is compressor. Second one, condenser. Third one, expansion valve. And the last one is the evaporator. Okay, so if you see, compression, condenser, expansion valve, evaporator. C, C, E, E. If you remember C, C, E, E, then I think it should be fine lah. Okay, C, C, E, E. C, compressor. C, condenser. E, expansion valve. E, evaporator. These four. Okay, C, C, E, E. Don't forget, C, C, E, E. Okay, let's take a look at the first part, which is compressor. This one. Okay, so this is the compressor. So what is the main purpose of this compressor here? Compressor here is the part where it will provide work to the system. As you can see here, closure stated that we must add work, okay, so that the heat can be removed from lower temperature region to a higher temperature region. So the compressor is the one that is providing the work. So what it will compress? Compressor here will compress a refrigerant. Inside this cycle here we have refrigerant. Okay, so what is a refrigerant? I will talk it more later on my next or maybe next video lah. Okay, so please stay tuned. Okay, so what will happen to the refrigerant in the compressor? Just like the name, compressor means that we want to compress. So if we compress, so means that what will happen to the pressure and also the temperature. Okay, this one here, because we want to compress, so the pressure increase, also temperature also increase. Okay, pressure increase, temperature increase. Okay, after compressor, the refrigerant with high pressure and also high temperature of the refrigerant will flow to condenser. This one. Okay, condenser here. So in this condenser here, as you can see here, it is mentioned that QH will be released to the warm environment. QH here. Okay, if you refer back to the closure statement here, QH is this one. Okay, released to the warm environment. Okay, to a higher temperature region. This one, QH here. Okay, so here what will happen to the refrigerant? Okay, when it goes to this condenser here. Okay, of course lah, when the refrigerant entering the condenser, pressure is high, temperature is also high. So what will happen after it exits the condenser? Okay, what will happen to the pressure and also the temperature? Okay, the pressure actually remain constant. Okay, this one here remain constant. Okay, didn't have any difference. Okay, didn't increase, didn't decrease. Okay, constant. But the temperature will decrease. Okay, maintain, pressure maintain, temperature decrease. What does it mean? Okay, so it means that the refrigerant is changing the phase. Okay, in this situation here, compressor here, you will compress the refrigerant in gas mode, gas state. So it will be a high temperature and also high pressure gas. Okay, and then this gas here will flow to this condenser here, and it will change its phase from gas to liquid. Okay, so this is what happening inside a condenser. So the one that is leaving the condenser here is liquid, refrigerant liquid. So this is where QH is released to the environment. Okay, when we want to change the phase from gas to liquid, means that we need to release the heat so that the gas can be changed to liquid lah. So this is, which is why QH is released to the outside. Okay, so quite long my explanation but hopefully you understand okay. So after it leaves the condenser here, it will enters this what? Expansion valve. Expand. Compressor, compress. Expansion valve, expand. So when we say expansion valve, therefore the pressure and also the temperature of the refrigerant here expand, means that pressure will low down. So pressure will decrease. What about the temperature? So at this point here, temperature also will decrease. Compress, pressure increase, temperature increase. Expand, pressure decrease, temperature decrease. Okay, so this point here, temperature is decrease. Okay, decrease. So after it expand to the inside the expansion valve here, the refrigerant will flow to this evaporator. Okay, when we say evaporator, evaporate. We say evaporate. Evaporate is something like maybe water is evaporating. Means that the water becomes gas. Evaporate. Becomes gas. Evaporator. So evaporator here, this refrigerant here, when it exits this expansion valve here, it will have a mixture of gas and also liquid. Okay, and then this mixture of gas and also liquid, when it enters the evaporator here, so evaporator here will receive heat from the cold refrigerated space. So means that the refrigerant will absorb the heat. So what will happen if a liquid absorb a heat? What will happen? So the liquid will change its phase to gas. Okay, so that is what happening inside this evaporator. Therefore, pressure, temperature. So inside the evaporator, the pressure is what? Constant, increase or decrease? The answer is constant. As I mentioned earlier, when the substance is changing its phase, the pressure will be constant. Okay, so this one here, the pressure is constant. So what about the temperature? This one here, the temperature will be constant also. Why it is constant? Okay, I will show you later. Okay, why it is constant? So in this part here, after the mixture of a liquid and also a gas, a vapor of the refrigerants exiting the evaporator, all of the liquid will change its phase to gas. Okay, and then after it change to gas, so it will enter this one. Okay, compressor again, and then the cycle will continue. Okay, so it is very important, okay, for the refrigerant to become a gas, before entering a compressor, because normally a compressor can only handle a gas, okay, not liquid. So if a liquid is entering this compressor here, it will be a high chance that the compressor will becomes not working properly lah. Okay, so we don't want that. So which is why when someone is setting up the air conditioning system, okay, they will check the temperature of the refrigerant before entering the compressor. Okay, so that the temperature is above the boiling temperature of the refrigerant to make sure that it change its phase to gas 100%. Okay? Okay, did you understand or not? Okay, hopefully okay, if you don't understand, so please repeat again my video. Okay, so let's map the process here on temperature versus specific entropy graph. Okay, so like this one TS okay, TS here. So T here is the temperature, S here is the specific enthalpy. Okay, so if you refer to this specific enthalpy here, the one that I mentioned about the compressor is this one. Okay, number one here is this part here. So if you look at this curve here, so this is the saturation line. This one So saturation means that when it is on the left side, okay, on the left side, so the properties will be liquid. Okay, so this is the part where it will change to liquid. And then at the left part here, at the right part here, okay, this is the point where the substance is changed to 100% gas. Okay, so it means that this part here is 100% of gas, this part here is 100% liquid. Therefore, when this refrigerant here enters this compressor here, it will be 100% of gas. Okay, so after that it will be compressed, pressure increase, temperature increase. So pressure increase, temperature increase, so it will be like this. Okay, so this process is the isentropic process. This one isentropic process. Okay, this one. So this is where the work is being provided. This one work. Okay, and then at this 2 here, number 2 here, it will flow to this condenser here. So when it enters condenser here, it will change its phase from superheated vapor. So at this point here, it becomes superheated vapor, and then it will change its phase until liquid. As you can see here. So that's why. So this is the process inside of the condenser, and this is where the heat, okay, from the refrigerant will be released to the outside or to the warm environment. This part here. Okay. So this is the part where it will enter this expansion valve here. This one expansion valve. So when it enters expansion valve, pressure down, temperature down. So this is why pressure down, temperature down, like this. Okay. So number 4 here. So number 4 here is in the middle of saturated liquid and also saturated gas. In the middle. So in the middle part is actually the part where it has the mixture of liquid and also gas or vapor. So number 4 here is the mixture of the liquid and also vapor of the refrigerant. Okay, and then it will enter this evaporator here. So this is why, as I mentioned earlier, pressure constant, temperature also constant. So this is where pressure constant, temperature also constant. Why? Because the refrigerant is changing its phase from mixture to 100% of gas. This is why temperature constant, pressure also constant. And this is also where the QL, okay, means that the heat from the lower temperature region will be absorbed by this refrigerant. So QL here, okay, and then it will change to 100% of gas. And then the cycle will continue. Okay. So if we plot our graph here on pressure versus specific enthalpy, this one pH, this one pH here, it will look like this. So actually it's the same thing, okay, same process here. Number 1 here is the compressor, pressure increase, temperature increase, this one, and then when it enters condenser, pressure constant. Okay, as mentioned earlier, this one So pressure constant, heat will be released to the outside. And then number 3 to 4, through the expansion valve, so pressure decrease, temperature also decrease, this point here. And then number 4 to number 1 is the evaporator, where the mixture of vapor, liquid vapor of the refrigerator will change its phase from mixture to 100% of vapor or gas. This one, so this is the part where the heat will be absorbed by the refrigerant, okay, or the heat will be extracted from the lower temperature region, this part here. Okay, so one more thing about the relation between QH, QL and also W. So we've learned before that in the first law of thermodynamics, it mentioned that the energy cannot be destroyed. Okay, so means that if the energy cannot be destroyed, so the total of energy, the heat, is equals to the total of work. Okay, this one, okay, so this is the relation, and we also learned in the second law of thermodynamics, it mentioned that Q in, okay, must be larger than work. Okay, okay, so it might seem a little bit of contradict, but it is actually the same thing. Okay, let me explain why. Okay, so if we refer here, we have QH and also we have QL and also we have W here. So the relation of QH, QL and W is actually this one. Okay, QH minus QL is equals to W. Okay, so this one here, QH here is actually this one, Q in. Okay, and also QL here is actually this one. Okay, this one is QL, and this one will be equals to W in. So if we see for this equation here, so the total of heat is equals to the total of work, okay, which support the first law of thermodynamics. And also if we look here, okay, what is the value of QH? So if we rearrange this one, okay, QH is equals to WH plus QL, this one. So means that QH must be larger than WL, this one. Q in is larger than W. So this thing also support the second law of thermodynamics. So therefore, this refrigeration system, which is the vapor compression refrigeration cycle here, didn't break any law of thermodynamics. Okay, it's still maintained. Okay, this law of thermodynamics. Okay, so if you have any question, feel free to ask me. No problem, I will try to answer it. See you again in the next lecture video. Bye bye.